Let's solve this problem by using our template. First of all, planning, framing. So let's start with framing. This is a dynamics, basically Newton's law. Let me write it here. We should use Newton's law because we have two objects and they're connected with a rope. So Newton's law is about basically forces, and the force is vector, so we need to pay attention to the directions. What else we can say? Frictionless pulley, no friction. This is very important. No friction here. Everywhere, no friction, which makes our problem much more simple. What else we can say? That's all, I think. Now let's come to the more details. What kind of forces we have? Since this is a force, many forces, and it has direction, so it's better to draw free body diagram. Free body diagram. For each object, we have two objects, so we need to draw free body diagram for each one. So now the equations that we can use, it's Newton's second law, F equal to ma, result force equal to ma. We need to apply it for both objects. What else? I think this part is enough. Now let's come to the free body diagram. For the first object, it has its weight m1g downward, and upward we have a tension. And in what direction it will move, for now we don't know. Let me assume it will move downward, and at the end we will check. Now that's all, I think. There is no any other forces acting on this first object. Let's come to the second object. Let's draw free body diagram. Downward we have its weight. Perpendicular to the surface we have a reaction force, and we have a tension. And it will move upward with the same acceleration because we have a string, we have a rope. That's all, I think. Now let's come to the solution part. We need to apply Newton's second law, F equal to ma, for both objects. Let me start with the object number 1. And this F is actually resultant force. So what is the resultant force for the object? For the first object, it's m1g minus tension, because we are assuming that it will go downward. So m1g should be greater than tension. So m1g minus tension equal to m1 times acceleration. This is Newton's second law for the first object. Now let's come to the second object. It will go upward in this direction. In this direction we have a tension. So we need to find basically resultant force acting on the first object in this direction, because this is the direction of the acceleration. So pay attention to this weight, mg. Mg has this component m2g times sine theta because of this angle, and in this direction we have a m2g cosine theta. Basically we are removing m2g, we are replacing it with its two components, m2g sine alpha in this direction and m2g cosine theta. So it will go upward in this direction because of the tension, and there is a m2g sine theta which is trying to stop this object. It acts like friction force. So m2g sine theta equal to, this is the resultant force in this direction, equal to its own mass times acceleration. They have the same acceleration because of the length of the string rope is constant, it's not changing. So I think that's all. Now we should make sure that these two equations are enough for us to solve this problem. How many unknowns we have in this equation? Tension and acceleration. Only two unknowns, and we have two equations, two formulas. So in terms of mass, we can solve this problem because two unknowns and two equations. So let me add these two. Further is just mass, totally mass. We finished our physics part here. So let me add these two equations to each other. So this one will be cancelled. M1g minus M2g sine theta equal to M1a plus M2a. From here, acceleration equal to, let me take gravity outside. So M1 minus M2 sine theta divided by M1 plus M2. Now let's use numbers. Let's substitute the datas. So acceleration will be equal to, let it be gravity approximately 10. Let's make it simple. M1 2 kilogram, 6 kilograms, sine 55 degrees divided by 2 plus 6. And acceleration will be equal to, here we can use our calculator. Divided by 8. Negative 3.6 approximately, negative 3.6 meter per second square. So now, next step we need to check. So why we have a negative acceleration? So basically, it will move in wrong direction, not wrong direction, in opposite direction. So we assume that first object will go downward, but at the end we understand that it will move upward because we have a negative acceleration. So indeed it will go upward, but with the same acceleration. The magnitude will be same, 3.6, just in opposite direction, that's all. So in this way we found the correct value for acceleration. So we know the direction basically. Now let's come to the part B, find tension. So we can come back to our original two equations, one of these two equations, and find tension. So first one, let me use the first equation, M1g minus tension equal to M1a. I can directly use this one. So tension equal to M1g minus M1a, M1g minus a. M1 is 2 kilogram, gravity approximately 10 minus negative 3.6 because it's going in the wrong direction. So from here, answer will be 2 times 13.6, 27.2 newtons. So let me check. We know that first object will go upward, so it means tension for the first object, tension should be greater than its weight. And we know that its weight equal to approximately 20 newtons. In order to move upward, tension should be greater than 20 newtons. And we have a 27.2 newtons, which is, I think, more reasonable. So answer is correct. So this was a part B. Now let's come to the part C. Part C. The speed of each mass 2 seconds after being released from the rest. So we know that it will move with constant acceleration, and the initial velocity equal to 0 because it starts from the rest. So and both objects' speed will be same because we have a string and the length of the string is constant. So we can use this equation: final velocity equal to initial velocity plus at. This is we can apply this equation for both objects because they have the same velocity at any time. Initial velocity equal to 0, acceleration 3.6 after 2 seconds, so answer will be 7.2 meter per second. This is the velocity of both objects after 2 seconds.